So now we know how to name molecules that are covalently bonded, and we know how to name chemicals that are ionically bonded. So we've got one last naming rule set that we're going to learn, and that is acids. So acids have their very own naming convention. So let's start by saying, well, what is an acid? So an acid is a compound that creates hydrogen ions in water. So when you add it to water, you have hydrogen ions. And so these formulas usually begin with the letter H. Okay, and in this class, we're going to stick with all acids that start with the letter H. There are a few exceptions to the rules, so just be aware of that if you decide to move on and take chemistry in college, that you will learn about some exceptions. But here at the high school level, we're going to stick with all acids that start with H. Okay. So here are some examples. You've got HCl, that's hydrochloric acid. HNO3 is nitric acid. H2SO4 is sulfuric acid. So how do you know how to name these chemicals? Okay, well, here's what we do. So if you see a chemical compound and it starts with the letter H, that should clue you in like, oh, okay, I need to use the acid naming rules. Okay, and then we're going to look at how many elements are in it total, including that letter H. So are there only 2 elements? Are there only H's and Cl's? Then the way that we name it is we first write hydro, then we end in ic acid. Okay, so start with hydro, end in ic, and the word acid. Always end in the word acid. Okay, so that's if there's 2 elements. Now, if you have 3 or more elements, that means you need to use your polyatomic ion chart and figure out who that polyatomic ion is in your compound. Okay, we are not going to use the prefix hydro. You only use that prefix if there's only 2 elements. Okay, so we're just going to look at the polyatomic ion chart, and if the polyatomic ion ends in 8, ATE, you change the ATE to IC, and then write acid. That's it. Okay, if the polyatomic ion ends in ITE, then you change the ITE to OUS and add the word acid. Okay, so when you have 3 or more elements and you have to use your polyatomic ion chart, you only change the ending of the word. Okay, if you have 2 elements, so you had to use your periodic table, then you add a prefix and an ending. Okay, so let's look at some examples. Okay, so we have HBr. Okay, so this means I only have 2 elements, so I go to my periodic table and I look up who is Br. Okay, and that is bromine. So first I have to add the prefix hydro, and then I change the end of bromine to ic, so this becomes hydrobromic acid. Okay, next one, H2CO3. So I've got H's, I've got C's, and I've got O's. So I have 3 elements. So I need to use my polyatomic ion chart, and I need to look up who is CO3. When I do, I see that this is carbonate, so it ends in ATE. So all I'm going to do is change that ATE to IC, so this comes carbonic acid. Okay. Next, we have H2SO3, SO3. So that means that we have 3 elements. So go to my polyatomic ion chart again and see who I have. And I see that this is sulfite. So I'm going to change that ite to OUS. But this one is a little bit special about spelling. You would think you just turn ITE to OUS, and so this would be sulfus acid, but that doesn't exist. So for this one, they actually, it's sulfurous acid, so they add the whole sulfur in there, okay? And that's one of those exceptions to the spelling rules that you just have to memorize. Now, in my class, if you were to write sulfus acid, you are still going to get credit because you are following that rule. Okay, but for those of you interested in going further in chemistry, or those of you who like to be perfectionists, I want you to know that The sulfite and sulfate both have that special spelling rule where you add in the whole sulfur and then add that ending. Okay, so just be aware of that. But if you were to write sulfurous acid in my class, you would still get your credit, and then I'd just leave you a little note. But don't forget spelling rule, okay? All right, so now let's do the reverse. What about if you're given the name and you need to write the formula? Okay, so if you see the word acid in the name, you automatically know that your first letter needs to be an H. Okay, automatically. Now, with these, we also need to worry about charge, just like we did with those ionic ones. So we need to check those charges, and if they do not cancel out, we need to crisscross them to make our subscripts. Okay? All right, so we have hydrofluoric acid. So that acid tells me, okay, this starts with H, so my first letter is going to be an H. Now, since it has hydro in the front, that lets me know that there's only 2 elements. So that means for fluoric, I need to go to my periodic table, not my polyatomic ion chart. So fluoric will be for fluorine. Okay, so I know my first letter is an H, I know my second letter is an F, and I need to check my charges. So if we look at our periodic table patterns, H has a charge of 1, positive 1. Fluorine has a charge of negative 1. So plus 1 minus 1, they cancel out, so I just write down my letters. So HF, and I'm done. Okay? Now, we have sulfuric acid. Okay? It does not say hydro, so that lets me know I need to go to my polyatomic ion chart to figure out what sulfuric would be. And it ends in IC, so that lets me know I need to find 8. So I'm looking for sulfate. Okay? And on my polyatomic ion chart, I see that SO4 has a negative 2 charge. Okay? My periodic table, I know that hydrogen always has a plus 1 charge. So plus 1 and minus 2 do not cancel out. So I need to be able to balance them, so I'm going to crisscross. So the 1's going to come down here. 1's understood, so I don't need to write it. 2's going to come down here. So this becomes H2SO4. Because with H2, that means I have 2 plus 1's, and SO4 is 1 minus 2. Okay, so 2 minus 1's becomes minus 2. Or plus 2, sorry, plus. I got my pluses and minuses mixed up. Okay, so we've canceled out those charges now. Okay, next, nitrous acid. Acid lets me know it's going to start with the letter H, and H is plus 1. Then I have nitrous, O-U-S. That means I'm looking for I-T-E, so I'm looking for nitrite. Okay. On my polyatomic ion chart, I look it up, and I see that that is NO2, and that it has a minus 1 charge. Okay, hydrogen always has a plus 1 charge, so plus 1, minus 1, those cancel out, so I don't need to do any crisscross, and I just write it down, HNO2. Okay, all right, so this is how we do our acid nomenclature. If you don't know what's going on, if you're confused, if you need more help, please get into contact with me so I can help you out, because up next is some independent practice.